Hello, my geometry students. This is note 7, and we are going to be talking about the Pythagorean theorem. So this is something you may have heard of before. It's a relationship between the side lengths if you have a right triangle. So if you look at the picture that you're given here, specifically we have a right triangle, and then the sides are A, B, and C. So it's very specific that A and B are always what we call the legs of the triangle. And then C has to be the hypotenuse, which specifically, that's the side across from the 90-degree angle, or the longest side, because that's your biggest angle, longest side. All right. So what the rule is that A squared plus B squared has to be equal to C squared when you have a right triangle. That is the Pythagorean theorem. So this is specifically for when you have a right triangle. All right, so let's put this to work. What that means is that down here, if you have a right triangle and you know two of the sides, you can find the third one by plugging into the formula. So in this case, the two legs, we can call this A and B. The side across from the 90, that has to be C. All right, A and B can actually be interchanged in this case. So if I plug on in for A is going to go the 2. In for B is going to go the 6. And then in for C, I'm going to put the X. All right. When we're squaring, we're multiplying it by itself. So 2 squared, you can do it on your calculator, or do 2 times 2, that would be 4. 6 times 6, 36. And then equals X squared. Add these together, so we would get 40. And then this is going to go back to unit 1. If we take the square root of both sides, square root of x squared just comes out to be x. For 40, we have to break it into perfect square times the leftover. So if you need to, you can always make yourself a little list on your paper of perfect squares. So 1, 4, 9, 16, 25. I think if you look at the front board, there's a list of perfect squares up there right now. 36, 49, 64, and so on. So use that list to help you, all right? So that means here, 4 is my perfect square, 10 is my leftover, and then the square root of 4 is 2. So 2 radical 10 is the value of x, or the length of that last side right there. Let's try it again. In number 2, the difference is where the x is. So x is one of the legs now, whereas 8 is the hypotenuse. So I can call x A, 4 can be B, and then C is the 8, the hypotenuse length there. All right, let's plug on in. So A squared would be x squared plus B squared, 4 squared, equals C squared. So we'll put it in 8 there, squared. Okay, square all the parts. X squared, 4 squared, 16. 8 squared is 64. Anytime you need your calculator, go grab one from up front. 64 minus 16, because I'm going to subtract that 16 over. That's going to give me 48. And then biggest perfect square, we go to break it down. 48, I believe, is divisible by 16. Yeah, right there. So 16 times 3 is going to be my perfect square, and then the leftover. So square root of 16 is 4, and then we're left with that radical 3. Keep in mind, I don't take the square root again, because that radical hat's gone. We've taken the square root. We are done. So that is the length of that missing side. I would like for you to try the next ones on your own. I'm going to quietly work through them so you can check your answers, but feel free to hit pause, try them, and then unpause it and check and see how you did. Right, so there's the first one. I hope you did okay with it. Right, take that square root. A number like 120, you might have to go searching for some factors. I'm going to use this little trick here that if I go 120 divided by x and then look in my table, let's see. So 4 times 30, guys, I think that's as good as it's going to get. So radical 4, radical 30, that'll be x. Square root of that's just 2, so 2 radical 30. So in case you were looking for a while, that's it. Okay, there's one other type of question we're going to look at today. When you flip it on over to the next page, you know, these ones, I like these ones. They're a little tricky because you got more than one x in the problem, but it still starts the same way. So let's label it with A, B, and C. So the legs need to be my A and B, the hypotenuse, the C. Okay, if we plug in, make sure A squared, I need to put that in parentheses and square it, plus B squared equals C squared. Okay, here's your Algebra 1 skills part. Take this to square it. You have to multiply it by itself. So you have to do x minus 2 times x minus 2. To do that, we got to do a little box multiplication. So maybe off to the side here, we're going to go x minus 2 times x minus 2. X times x, x squared. X times negative 2 would be minus 2x. X times negative 2 again. And then negative 2 times negative 2, that'll be positive 4. Okay, bring it on over. X squared, these two together, minus 4x plus 4. All right, and now we have to keep going. 4 squared would be 16, and then equals x squared. So take a second and make sure you have all the parts. So x squared minus 4x plus 4. Bring down this 4 squared, that's 16. Bring down that x squared. Okay, from here, I want you to combine your like terms. So because they're on the same side, 4 and 16 I can combine. So I'm going to get x squared minus 4x. Those two together will give me 20. And then equals x squared. I have x squared over here and over here. I can move that x squared over. If I go to move that x squared over, it actually cancels right out. That makes my life a lot easier. When you bring this down, I get negative 4x plus 20. Now it's equal to 0. All right, from here, you can either subtract the 20 over or maybe add the 4x over. Doesn't matter which. If I subtract the 20 over, I'll get negative 4x and then equals negative 20. When I divide by negative 4, I'm going to get x equals 5. And I'm done. Oops, right off the page there. So when I go back, the hypotenuse was x, so that's 5. And then this leg was 5 minus 2, and so it actually comes out to be 3. So my side lengths are 3, 4, 5. Right? We're going to try that same thing again. I'm hoping I left myself enough space here. We're going to see. I'm going to slide this over a little bit. Take a look. A, B, C. Make sure the hypotenuse always C. A and B you could flip-flop. All right, if we plug in to a squared plus b squared equals c squared, x is first, 12 goes next. And then because it's a binomial, put it in parentheses, x plus 4 squared. All right. This would just give us x squared. 12 squared is 144. X plus 4 squared. You know we have to do a little bit of work. So I'm going to make some space over here. X plus 4, x plus 4. All right. This gives us x squared. 4 times x is a plus 4x. You're going to get a plus 4x again. And then a 16 when we do 4 times 4 there. Okay, I'm going to put it all together. That'll give me x squared. These two, 4 and 4, will give me plus 8x, and then plus 16. And then I'm just going to bring this on down. X squared plus 144. Right? Just like last time, we have to combine our like terms. So remember, if I move across the equal sign, so I'm going to move the x squared over, and just like last time, it actually cancels right out. So I get 144 equals 8x plus 16. Now I just have to get the x all by itself. So move the 16 over. So if we do 144 minus 16, that'll leave me with 128 equals 8x. And then divide by 8. That'll give me x equals 16. So there's my answer to number 6. And if x is equal to 16, I'm going to go back up to my picture. That means this side length was 16, and this is 16 plus 4, so that side length comes out to be 20. Right? There's one more like it. I want you to try it. Again, if you need to, pause the video, try it, and then unpause and check out and see how you did. How'd you do? Should have gotten x equals 8. Then when you plug back in, you have side lengths that are 6, 8, and 10. All of those examples, when all the numbers come out pretty, are examples of Pythagorean triples. All right. If you're up for the challenge, there is one more page with examples on it where you have to find a missing side length first and then the last part. Otherwise, if you're okay with these, what I'd like you to do is go on and try the homework. And the homework is homework 7. And I just want to quick check. Let me take a look here. Homework 7. You can definitely do all the front. You can do all the back, but you can skip the bottom. So basically you're doing numbers 1 through 6 of the homework. All right. So homework number 7, you're going to do numbers 1 through 6. Give it a try. And make sure to submit your work when you're done. Thanks, guys.